Today's learning goal, short and simple. I can write and solve proportions. Before we start talking about proportions, we have to have an understanding of, some other, like, the parts of their definition. Does anybody remember what the definition is for a proportion? We did the vocabulary. Anybody remember what that is, Hayden?
A statement that two ratios are equivalent.
Okay, a statement that two ratios are equivalent. Well, statement tells me that there's going to be it's an equation. And ratios, well, that was another one of our vocabulary words, and we're going to first deal with those. And equivalent means what? They have to be the same, right? They have to be the same. So what is a ratio then? A comparison of two quantities by what? By division. Yeah, by division. What operation really is, going on in a ratio? When you're comparing two quantities, it's by division. So the comparison of A to B, if we're comparing A, which we have no idea what it is, to something else B, which we have no idea what it is, it could be written as A colon B. Now, notice that when the comparison is given to us in words and they say A to B, A has to come first. It has to be first in the way that we display it. Or it could be written how else? What's another way we can write ratios? If it's a comparison of two quantities by division, what's another way to write it? You didn't learn that when you were doing your SQ3Ring, Benton?
As a fraction.
As a fraction. So A over B. A to B. The fraction bar is like our word 2. But notice what I say there. B cannot equal what? What can't be equal when you have a division problem and the B is your divisor? It's downstairs. What can't you divide by? 0. Yeah, we might have said it, but some of you were saying it so weak that B cannot equal 0. So in a ratio, in a comparison, you cannot compare them with 0 being the second thing in your comparison. Now, actually, the colon, that's right here, in mathematics also means division. In other countries, such as, back when I was teaching in, I believe it was, no, I was in Lakeville, Minnesota teaching, I had a student from Kazakhstan, and he would never use the division symbol or the fraction bar. He would always use the colon because that means division. So I had to get used to that when he meant division, he would use, the colon. A statement that two ratios are equivalent is called a what? Proportion. So we have a ratio, a comparison of two quantities by division, equal to another ratio, another comparison of two quantities by division. So what did you learn about the cross product property? What does the cross product property allow us to do? Oftentimes students like to, when we're multiplying fractions, they like to say you cross simplify. There really isn't such a thing. But what are cross products? Well, first of all, products means what? Multiplication. You have a resultant because of a multiplication problem. And then cross, what are they? What did you learn in your reading and studying of the lesson before you got here today? What does the cross products property allow us to do? Well, okay, then let's back up a bit here. What can't B be in this situation here where we have A over B equals C over D? It can't be what? 0. And D can't be, neither of them can be 0, can they? Okay. So the cross products property says if you do some multiplying products, the multiplication of one should equal the multiplication of the other. So what are our factors in these two multiplications? What's the cross part? Anybody want to take a stab at it? Pretty sure this is in your reading. Avery?
Sure, A times D equals B times C.
Yeah, A times D. the numerator of one of the ratios times the denominator of the other ratio should be the same as taking B times C. So the denominator of the first ratio times the numerator of the other. So basically what you have to do is you have to take a numerator of one times the denominator of the other. It should equal out when you do it for both ratios. Okay, so since that's such a handy property, it allows us to solve algebraic equations that we can set up as a proportion model. The proportion model is actually one of the most useful models there is for problem solving. If you have 3 knowns and 1 unknown, maybe you can set up a proportion model. I'm not saying always, but maybe you can set up a proportion model to help you problem solve. So what would be our multiplication problem we could set up in this one? Avery?
-5 times E equals 2x.
And I want to see this on your papers. I want to see you set up this cross products. This is what we're doing here. We're setting up the cross products. Okay, what's the product of the left side? What does it become? -40. And the right side? 2x. Okay, well now we have an equation still in one variable that we know how to solve. What are we going to do, Chase?
Divide both sides by 2.
Divide both sides by 2. Thank you for saying it correctly. Divide both sides by 2. And when you do, you get
X equals negative.
x equals -20. So basically, when we sub that back in, it should make it true. Or maybe another way to think of it is like this. If we put -20 in right here for this x, could -20 over 8 simplify to -5 over 2? What goes into -20 that also goes into 8? What's the largest factor you can think of? Go ahead, class. 4? Yeah? Okay, 4. So how many times does 4 go into -20? 5 times. How many times does 4 go in? Well, -5 times, right? And how many times does 4 go into 8? 2 times, -5 halves. So what you end up with is a fraction. That's just another name for the fraction that you have both parts of, right? Well, not always are they quite that basic. Sometimes we have other things going on in them, such as this one where our numerator has 2 terms. It has an algebraic expression with 2 terms rather than a numerical expression or just an algebraic expression. So let's set up our cross products for this one and be really careful because this is where sometimes these problems go wrong. Can we take the 4 and multiply it times the g plus 3? If we write it like this, 4 times g plus 3, just the way it looks, right? Equals 7 times 5. Can we do that? By the way, in multiplication, remember, does it matter what order you multiply in? No. So if the denominator gets to be first instead of the numerator in that cross product, does it matter? No. How do you feel about the fact that it's 4 times g plus 3, the way we wrote it? Is it okay? Why does it have to be in parentheses? Macy, you want to help out?
Because you have to multiply 4 times g and 4 times 3.
The 4 has to be multiplied times the whole numerator. If we leave the parentheses off right here, order of operations says take 4 times g and then add 3. We would not be multiplying the 3 also times the 4 like we need to. So very important that that goes in parentheses. Don't write it without it, I'll count it wrong because it won't get you the same result. And then we're going to have to do some simplifying over here. What does this side become?
4g plus 12.
4g plus 12, because now we got to do our distributive property, right? And the other side is 35. Okay, go ahead and finish solving this one. Sometimes we feel like we did something wrong when we don't get a number that is a multiple of what we're dividing by. Is 23 a multiple of 4? No. So you're like, oh, what did I do wrong? Are we always going to get whole numbers or integer values? We won't. So give me some options for ways you might see this in an answer bank that are legitimate. There are a few. What's one of them? Macy, what's one?
5.75.
Okay, 5.75. And why can we write this one as a decimal? Because it's a nice decimal. It terminates. Yeah. This one. So this would be one way. Or what would be another way we could give this answer?
5 and 3
That would-
fourths.
Kate?
5 and 3 fourths.
5 and 3/4. Or what would be another way we could give this answer? Just possibly it might be in an answer bank like this. Benton?
G equals 23/4.
Or G equals 23/4. Because it can be left as an improper fraction as long as you can't simplify it in its improper form. So is there anything that goes into 23 that also goes into 4 other than 1? No. So we have 3 options here of ways we might see this answer in an answer bank. Or that I could not count incorrect on your assessments unless I said, give it the answer as, I'm specific on it. So any questions on solving proportions using the cross products method? Okay, let's go to the back side. As I had just stated a little bit ago, proportions can be used to problem solve. And here's my caution. Carefully set up your comparisons. Don't make comparisons that are not good comparisons. Okay? So if you're comparing, dollars to acres in one ratio, you can't switch around and compare acres to dollars in the other ratio. Your comparisons have to match. Dollars upstairs here, you gotta have dollars upstairs here. Acres down here, you gotta have acres down here. Okay? So you gotta be really careful about that. And then the other thing you have to be careful about is, it says the ratio of games won to lost, games won to lost. So they're basically telling you then that the first number in the ratio is going to represent what? Games won. And the other number in the ratio, the denominator or what you're dividing by, is going to represent the game lost. So the order that they stated in the words is the order that it's going to be in the ratio. So when we set up our ratio for this, we're going, and I want to see this, I really do, because this is how you will learn to set them up properly and not just be haphazard about it and just the fact that you have 3 numbers, just throw them somewhere. I want you to write in your proportion model, something like, you don't have to put games, you can just say 5 won to 3 lost. We're going to set up another ratio with the rest of our information. If the team has won 70 games, how many have they lost? So where are we going to put that 71? On the top. We need to have the same comparison going on here. And what's going to go downstairs? Lost. So X, lost, or whatever variable you want to choose. So in your setup, I want to see some labels that will help show that you've made a good selection. Now, when you're setting up your cross products, you can ditch your labels. Okay, go ahead and solve this. You don't have to have the labels in your cross products. Show your cross products in solving the equation. How many games did they lose?
42.
42. 42 games lost. We're going to give it its label. 42 games lost. Okay, now I want to make sure that you understand that that does not mean this is the only way to set up this proportion and get the right answer. but there are incorrect ways also. Can anyone think of another way we really could have set up this proportion and still gotten 42 gates as our answer? You would have been okay. Benton?
Divided 70 by 5. Take it times 3.
No, I'm not coming up with another way to solve it, I want another proportion. I want another proportion model. Because there was, one of the first things you had to do in your SQ3R when you were doing your checkout problem for example 1, and you set up your proportion model, did X end up downstairs like it did here? Should have. And then, but yet you hadn't come to the cross products part, right? They were solving it by multiplying by the denominator. Does this sound familiar to anybody? Well, I guess not. Well, let me show you what else we could have done. Even though I said we have to go in the order it says there, we have to go in the order it says there so we make sure we get the right labels on it. We could really actually also set this up 3 lost to 5 1 equals X lost. Oopsie. Need some more room here. Lost to, how many were 170? Would we have the same cross products from this? 5 times X? 3 times 70? Yeah. Could we have done this? Could we have done 3 lost to X lost equals 5 1 to 71? Could we have done that? We're comparing the games lost to the games lost. Well, the ones that were lost in the 1 ratio have to be across from the ones that were 1, 5 1 to 71. Would it have the same cross products? So there is more than one way. There is more than one way to set up these proportion models, but there are also some incorrect ways. We couldn't set it up 3 lost over 71 and 5 1 or X lost over 5 1. We couldn't do that. We couldn't switch those around. So we have to make sure we do a good setup. Okay, go ahead and do that last one on your own then. Make your own setup. You get to decide. Make sure you use labels in your proportion model in your setup. Do you get a $48 sale price? Did you set up your model exactly the same way I did? You might have. Does it have to be that way? Is that the only way? No. But what should happen is, no matter how we set up our model, we better all be taking the same, we better all be doing the same multiplications. On one side, we better be multiplying 3 times 64. On the other side, we better be multiplying 4 times x. Somehow we need to come up with the correct setup. Now, let's go back to, and well, let's do this one first, and then we'll go back to the other one. Does this answer make sense? Give me a reason why it makes sense. Eddie?
Answer prices lower.
Yeah, you want your sale price to be lower than the original price, right? I don't think any of us are going to go into a store and if something's marked $50, and they say on sale at 75, we're gonna be willing to, do that, right? We're gonna fight for the original price then, at that point. So the sale price ended up lower than the original price, so it seems like a reasonable answer. We shouldn't move on to another problem if we don't get a reasonable answer. How about back up here where we had 42 games lost? Is that reasonable? Why? Why is that one reasonable? No, Eddie's not gonna come here and but thanks for offering. Why is it reasonable that they lost 42 games? Don't make this hard. Just some sensible, common sense reasoning. Should the number be smaller or larger than 70? Why? Because 5-3, they won more games than they lost in the original ratio, right? They're winning more than they're losing. So if they won 70, we better end up with a number that is less than that. They're going to lose less games than 70, aren't they? Okay. Any questions? Okay, let's get your assignment written down and use your notes as your guide that you know what I'm going to